screen.
Yes, yes.
Yeah, thank you.
So I'll get started. As I said, I've just put this slide somewhere I found from LinkedIn, in which this heroine is saying whether whatever things that you gave as part of the robot, was that related to AI and ML is integrated or in it or not. So as of now, many of the times, many of the robots that we provide, some of them do have good amount of AI inbuilt into it, but there are also, as of now, a lot of robotic platforms where even basic programming is done, and it provides a lot of applications. Not necessarily AI, but without AI also, as of now, a lot of applications are running. So what we look at as AI in robotics and how it changes as per the applications, that is what my presentation is going to more or less cover today. Okay. So a little bit about me. I started about 13 years ago my journey in robotics. We started with these kind of humanoid robots on the left side corner. Then we started working with mobile wheeled robots. Then there are robotic arms. The people who I am speaking to, are they doing undergrad or postgrad, sir?
No, no, all are, I think, faculty from postgraduate and PhD research
Okay, okay,
scholars.
great, great, great. For faculty from postgrad related to AI and
Yeah,
robotics.
yes, 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 yes.
Okay, so uh, so okay, then I'll tune it just that way. So this talk is usually for those, anybody, it could be researchers, students, or professors interested in robotics. And then what I'm going to tell you about my own robotics journey also, as well as in the past 13 years, I have also partnered with a few people to build some robots, to build sometimes some parallel robots, as well as we are also making our own mobile wheeled robots now. So I'll tell you about that journey also. And so basically, this is what I would put for undergrad people, that anybody wants to enter a technology usually when it is exponentially growing. And these days, robotics, artificial intelligence, these are quite the buzzwords. And everyone feels that everything about robotics is generally in the exponentially growing stage. But that is not the case. Some applications of robotics, let us say medical robots or defense robots, you might find them somewhere into the exponential growth of the technology spectrum. Whereas there are some robots like us, let's say industrial robots, you will find them in the where the technology maturation has actually happened. That is, these technologies have been existing for a long time, and there is a lot of maturity that is already happened in over there. So this is what I had mentioned as Thakur Baldev Singh. So he in his iconic film Sholay basically talks about that Loha Garam Hai Mar Do Hatoda is his famous dialogue, in which I look at it at the way that he's encouraging people to get into technologies by being at the right place at the right time, and of course being the right person to achieve that specific goal. So, but overall, as far as I see in the past 12, 13 years and in the coming 13 years, robotics does seem to be growing in quite a good stage. Like every year we are seeing a CAGR of around 20%. So that's quite a lot, especially in the past 20 years. And I also feel that robotics is like the natural next best thing to happen. Because if you look at the past, right from the 90s, our first best friend, electronic best friend, was a computer and a laptop. In the 2000s, our second best friend, without which we cannot live today, is the mobile phone. And quite possibly, our third best friend might be some kind of a personal robot which comes into our house. It might enter our house as a simple sweeping robot or a cleaning robot, but it might not remain a sweeping and cleaning robot. This is not a PhD thesis and prediction that I'm doing, but it is just my gut feeling from whatever past 14 years I have been working in the robotics, and whatever evolution I have been seeing in robots. Quite possibly, I feel when people think of robotics, and if it is going to be ubiquitous, that is, it is going to be omnipresent in the lives of all human beings, then it will probably enter people's houses as a floor cleaning robot or a floor washing robot or an entertainment robot, some this kind of a personal gadget kind of a robot. But I also feel that it will not remain only as a gadget or a sweeping robot. The reason I say that is from our experience of the mobile phone. Like for all of the us who remember the using the mobile phone in the late 90s or the early 2000s, it was initially used only and only for speaking to each other. But it is only been in but as we have seen, hardly anybody of us today uses the mobile phone just for speaking to each other. It is being you. I book my flight using it. I book, so there is an app called Make My Trip. I book my taxi. So billion-dollar companies like the taxi booking app like Uber and Ola have come into existence. Then any kind of payments that we make to each other are also through phone. Entertainment, if you look at it, people have almost replaced watching TV with watching the phone. So what started as a communication device is hardly being used only as a communication device. Similarly, I feel that once robot enters people's homes, it might, a sweeping robot will not remain only as a sweeping robot throughout its lifetime. Quite likely that it will be graduated into an entertainment robot also, security robot also, and number of applications, some of which we can see now and some of which are not visible right now. They might start happening on the personal robot front. Now, when we talk about robots, I'll just show you a video of the kind of robots we are making, and I will also explain each part of the kind of robots we are making and what I will explain the sensors in it, and what is how we make sense of the sensor data, which is related more to sensor integration and giving the data into the robot. And after that, to make sense of the data and to command the robot to do certain actions, that is where AI is going to play a big role. So I'll just turn on this video, so just take a look at the robot. Hello friends, I'm Aditya Marate from Next, and what I'll be doing in this video is showing you a quick demonstration of the mobile manipulator that I have with me. And after the demonstration, I will quickly explain the different parts of this mobile manipulator. So here we go. I'm controlling it in a teleoperated fashion using a wireless joystick. So this is the joystick which just increases its speed. So I can move it forward, backward. Can also move its direction. Rotate it. Besides this, since it has this beautiful mechanical wheels with rollers, I can also move it sideways. So these were the movements of the mobile wheel robot. Now take a look at the robotic arm. It is a 6 degree of freedom robotic arm with a 2-finger gripper, which can also be moved. So presuming we are holding something over here at the gripper, I can move this robot forward, move it back, move it to the right, to the left. Can move it down, move it up. I can also make it a bridge rest mode in which this point will remain exactly where it is, and all the other joints of the or all the other actuators of this robotic will move around this point. So it will, the action will be like this, up, down, this way. So you can see this is moving up, keeping this point where it is. This is going down. This is again, we can move to the left. Or to the other direction. You can also rotate the gripper itself or open that close. So this was the basic working of the arm per se. Now, besides the mobile robot and the robotic arm, there are also a few very interesting sensors in this. So there is a camera and that sensor right above it. There is also a LiDAR, which gives a 2D map of the surrounding for this robot. Then inside the robot, there is an IMU, which is an accelerometer to get the speed of the robot, a magnetometer to know the direction of the robot, and third is the gyroscope to get the roll pitch and yaw angles of the robot. So all this sensor data goes to the controller of the robot, which is right inside this robot. This robot is presently working on the robot operating system, and we can program the whole mobile manipulator to move it autonomously by doing obstacle avoidance also. So you can write algorithms in it to do mobile manipulation such that it picks up from one point of the room, picks up an object and drops it at another place. So you can do a lot of algorithms and software using this mobile manipulator, which we'll be looking at in the subsequent videos. Thank you very much for looking at this video, and we will talk more about the technical aspects in much more detail in the coming videos. Thank you. So this was just to give you an idea of what we do. Besides that, now I just showed you. So making all these kind of mobile manipulator is nothing but human beings' quest to make someone like them. You have seen, we all see all the movies in which we are trying to make humanoids and all that. Of course, humanoids are not that common. Humanoids is robots which are like two-legged. So two-legged or four-legged robots, they are not that common. Most of the robots as of now which are running in the industry are wheeled mobile robots on which a robotic arm is placed. Now, what I will do is, in case we have to build this kind of a mobile manipulator, we just in that video saw how we achieve omnidirectionality in robots. For example, if I want to create a robot like myself, which should be able to move around and get me a cup of coffee from somewhere, etc., these kind of things. One is it should have legs. Instead of that, we are giving 4 wheels over there. The second is, just like human beings, it should also be omnidirectional. So in omnidirectionality is achieved currently in these mobile robots by having either 4 motors, and for like each of the wheel being controlled by a separate motor, and that way you can do it. And alternatively, there is also the option of mechanism wheels, which you right now saw in the video. There like each wheel is having certain rollers, 10 or 12 rollers in each wheel, because of which it achieves omnidirectionality. It can move not just forward, backward, and it cannot move just like a rickshaw, but it can also move sideways. So that video, this movement that you saw of moving completely sideways. So this is the effect of mechanism wheels per se. So that is how mechanism wheels are used. Besides that, if I'll just mention in brief what are the sensors that we put. Human beings, we have eyes to analyze and perceive the environment, but we can see not only 2D data, that is, my eyes are able to see not only 2D data, but also 3D data. That is, if you go and look on YouTube as to how human beings see, then we see not only the 2D data, I know the distance of each object from me also. The way we do that is by using various algorithms actually. That is, in a train, whatever looks far, that is, if the lines are going far away, that must be a far away object. So this is how algorithms are already pre-inbuilt in our brain over a period of time. That is how we try to find out which one is bigger and which one is smaller, which one is farther away, which one is closer away. So related to relative size, or related to the texture gradient, or the light and shadow, there is interposition, there are various algorithms, there is various algorithms which is running already in our brain, which is helping us analyze the 3D depth sensing data. Otherwise, this cup of coffee, how do I know what is the distance of it? I like the Batman, or like this bat, like the bat birds. We do not have a we do not use sonar to find out the depth sensing. We do that analysis, or animals many times do that analysis, just by using all these existing experience, as well as using these kind of algorithms. So that is why when you go actually in some museum, they are going to play with your algorithms to make a fool of you. That is how they do it. The mirrors and all that, they are designed in a way such that your set algorithms are done. So how do we do that in the when it comes uh, to robots? One is we provide them a camera, of course, but we also provide them a depth sensor. In robotic parlance, we call it as a lidar. In case anybody is already doing MTech or PhD, they might be knowing lidar. So a lidar is of two kinds. One is a 2D lidar, which gives, the lidar is nothing but a light pulse is sent, it gets reflected back, and by the time it comes back, you know that you can calculate the distance of that point. If that sensor is moving rotational, then you will get the 360-degree points, and in this way you will get a 2D map of the surroundings, or you can say the 2D depth data on a single line. And if that sensor is also moving up and down, then you will get a 3D 3D data of the surroundings in terms of depth sensing. So we have put on the robot either a 2D lidar or a 3D lidar. If the mobile robot is just only being used, then a 2D lidar is enough, because the mobile robot just moves in X and Y direction, whereas the robotic arm moves in a 3D, in the Z direction also. The robotic arm can move up and down. So you'll require a 3D lidar on top of that. So this is one comparison. Besides that, if you look, so this I have already explained, lidar, how the lidar works, etc. Besides that, there are also other sensors in our body which gets compared with this. So the second is, besides having wheeled robots, as you know, there are also robots which you must have seen these four-legged robots from Boston Dynamics, uh, or two-legged robots also, the humanoid robot. There is a robot called Asimo from Honda. For all this, if the robot is going to change its plane, that is, it is going to move up the staircase and all that, you will need to know the roll, pitch, and yaw also. So for that, in the human bodies, what we have is, there is a sensor behind our ears. When we move sideways, we come to know the roll. Like this, we will come to know the pitch, that is in the y direction if we are moving like this, and like this we will come to know the yaw. To replicate this sensor in robotics, what we have is a gyroscope. So that is how we get the gyroscope data. And besides that, besides the gyroscope, there is also, to get the speed, that is at what speed the robot is moving, or what speed we want the robot to move, we put a accelerometer. And to get direction, because we also need to tell the robot to move from point A to point B, right? And we also need to give it direction. So in humans, we can intuitively try to understand the direction from the context, from the data we are seeing. But in the robot, we give it northeast, west, south using magnetometer. So these three sensors the accelerometer to give the speed and velocity, the magnetometer to give direction, and the gyroscope. These three together are called as the inertial measurement unit, IMU, which is also something that we put in the robots. So we covered the camera depth sensor. We put a LiDAR on the mobile robot. We also put an IMU, LiDAR for depth sensing, the IMU to give it to know about the speed, direction, and the roll pitch yaw in case the robot is falling backward or forward, that kind of thing. Now, if you are moving the robot outdoors, you can even ask the robot to move from point A to point B in a simple fashion. That is the GPS. Most of our phones also, you must have seen they have a GPS also, or our smartphones at watches also. They give us GPS data. But when you are working indoor, there is no GPS. So when it comes to autonomous navigation of the mobile robot, if we want to achieve autonomous navigation of the mobile robot indoor, we will have to work without a GPS. So how we achieve that is similar to this movie. Have you seen this movie? Three, four blind people trying to rob a bank. Something like that we try to achieve. So how they do that over there is how blind people can move within known spaces. Within known spaces, a blind person can move from point A to point B if he already knows the environment beforehand. So he counts the number of steps, 3 steps ahead. Then you turn right and move 4 steps in any direction. Then you can know the. Sorry, I have just put up this video because this whole movie is based on making blind people uh, learn by heart a certain bank, and then they go and loot a bank. That is what this movie is. And later on they loot the bank and nobody comes to know. I mean, nobody believes that this can be done by blind people. But anyway, when it comes to robots, when there is no GPS, how do you tell it to move from point A to point B? It looks like it is blind in terms of positioning, right? So what it does is similar to how blind people count the number of steps, we will count the number of turns of the wheels. So presuming that the first position of the robot is known, then just we will tell the robot to move 4 steps, four rotations ahead. Then using the magnetometer, we will ask it to turn right or left, and then again 3 steps ahead. And then over there, maybe somebody is going to pick and place something on that object, and then again it will go to another position. But every time we will just ask it to rotate the number of turns of the wheels. We will perhaps also ask it to move at a certain speed. If somebody comes in between, because of the LiDAR, you know that somebody is coming close. Because of the depth sensing data, it will stop automatically, and then it will keep on moving. It will turn because of the magnetometer. So basically, encoders in the wheels is what we put to get the exact number of turns. And there already exist these kind of open source codes available in the open source robot operating system. Otherwise, you can develop it yourself also using the data from the encoders. Using the magnetometer, you can ask a robot to move from point A to point B with very good accuracy. So these kind of algorithms are already working in ROS. In case any of your colleges in which you already have a mobile robot, I'm sure then you will have already run through these kind of algorithms which are called as simultaneous localization and mapping, and or you can call them autonomous navigation with obstacle avoidance in indoor GPS GPS denied environments, basically. So this is how the indoor environments of navigation work. So I think I just try to compare human sensors. I think I have covered them all. Yeah, seeing movements, moving by obstacle avoidance, not falling, the gyroscope, and usually most of these mobile wheeled robots that you see, their power is coming from either the lead acid or lithium ion batteries. So you might think that yeah, there is a lot of cars being driven by batteries, but who is going to drive the robots? In fact, for every one car that you drive, it is anticipated that there will be more number of robots per person than the number of cars per person. I mean, it is not visible, but and not necessarily even available in homes, but a lot of factories, like most of the warehouses that you see, Flipkart, Amazon, these are already using mobile robots for sorting of samples, for moving the things from one point to another. So that is one of the most highest deployment areas and deployment applications of robotics as of now. Large companies, like recently one of the success story in India is a company called Adverb, if you have heard of that. And before that, there was a company called Grey Orange. They started with a turnover of a few crore rupees sometime in 2017, and then by 2024 they have a turnover of hundreds of crores. Grey Orange is even older, but Adverb grew really spectacularly in the past few years. But there are a lot of these kind of mobile robot companies, like maybe 4 or 5 big names, which have been growing exponentially into the field of warehouse automation, in which robotics plays a major role. So I'm not going to. I'm not speaking only in terms of the hardware and the technology. I keep on digressing also to the applications and what is happening in the market. So because I have oriented this thing also to give some idea about entrepreneurship, because robotics and AI is one field where there is more lot of scope for entrepreneurs. uh, some are doing really well like Adverb, some are doing mid level. But yeah, so that is also another career opportunity. So I touch upon it once in a while, along with the pricing also. So yeah, this is what I've covered. So this is the what the basics of robots go. Then instead of a single, we can have two of them also. So besides the sensors that are there in this, just hold on, I'll just show you some more sensors also. Let me see if I have this video. Run robot. Yeah. So hello, this is Aditya from News. And what we have today over here is two five-finger grippers, this type integrated. So initially, robotic arm. So look, there is an evolution even in robots happening continuously. Okay, every part of the robot also provides an opportunity for starting a new company. Like I told you about the mechanism wheels. Now, if there are going to be hundreds and thousands of robots, as I'm saying, which are going to come into the foreplay or which are already coming into the picture when warehouse automation robots is happening. MRF tires you might have heard of, but is there any company which makes mechanism wheels which you can immediately remember? Perhaps they will not even be advertising, but they are already saying thousands of wheels. Similarly, there are some companies which focus on making only grippers. So the gripper that I showed in the previous this thing was an imported company. This five-finger gripper is a gripper that is made in Hyderabad. So I purchased these grippers for them from them, and we have given this robot in dual arm configuration. So instead of a single arm, a single hand, if a person has both hands, obviously you can do much more things with it. So this is a dual arm robot. This is the third generation robot. I'll just run this video. This is working in dual arm configuration, and I will also show you how this 5 finger gripper and all that is. There is an evolution in grippers also. The right thumb, this is the left one, with my left thumb. So this is this is Aditya from Userx, and what we have today over here is two 5 finger grippers. This side integrated with the robotic arm. This is the right hand with the right thumb. This is the left one with my left thumb. So this is both the robotic arms. I'm controlling together using this joystick. I'm going to put it in Cartesian mode so that I can move this forward, back, the y-axis, or in the -1. So whatever object I am carrying, I can move it in x, y, or z axis. This is the y, and this is the z axis. So this now is the orientation mode. Whatever objects that you might have held in hand, you can move the object. You can move your gripper around it, considering that as the center position to the right. So this is the orientation mode. One is the translation mode. You can move the robot in the x plus x, y x plus y minus y plus z minus z. And in the orientation, with whatever object is kept in your hand, you can move the hand around it. So this is the orientation mode in any gripper, in any robotic arm. This is a 6 degrees of freedom robotic arm. It is only if the robot arm is fully 6 degrees of freedom, then you can do the translation as well as the orientation. Otherwise, there are limitations in 4 degree, 5 degree. Some limitations are there because uh, it is related to the mathematics of robots. If there are only three motors, you can resolve the x, y, z. So you get only Cartesian movement. And if you want to resolve the theta x, theta y, theta z, then you will have to do this also. What is it called? You will need three more motors. So it becomes a 6 degree of freedom. By the way, every motor is called a degree of freedom. So this I wanted to tell you. Besides having this video, I ran not for moving, showing you the movement of the robot, but this part. Just like there are sensors outside the body of the robots, more and more sensors are going to be put inside the body of the robots also, because my hand, when I ask it to move from point A to point B, if something comes in between, it should stop and it should go around it. Or if somebody comes and pushes my hand, it should move. This kind of a robot is called as a collaborative robot. I hope I am not being too preliminary, but since everybody is post grad, but that is what I have designed this presentation for both. Okay, so this is what a collaborative robot is. Now, how they have done is, at each and every actuator, they have also put a force and torque sensor in each and every motor. That is, this is the first motor. This is the bottom first motor, second motor. Then there is a third over here, fourth, fifth, sixth. Every ring that you see is a motor. So that if somebody pushes from outside, it should be compliant. It's called as a compliant robot or a collaborative robot or a smart robot, if you want to call it that. So I'll just show how it behaves. Right now, I'm just going to push the robot around to show the compliance. So just by pushing the robot externally also, I should be able to move the robot. Otherwise, if you create a humanoid, this robotic arm with this 5 finger gripper, so we can integrate it with any other kind of grippers like 2 finger or grippers. These are extremely lightweight, low power consumption robotic arms, which can be placed also on mobile wheeled robots, due to which we will convert your mobile robots into mobile manipulators. So two dual arm mobile manipulators, so dual arm mobile manipulators picking and placing objects and fully safe to use as these are completely torque compliant robotic arms. Thank you. So this robot we had given to Bhaba actually. Anyway, Bhaba Atomic Center. So what I wanted to tell you mainly about is this AI. AI at the hardware level depends also on the evolution of sensors, on the evolution of hardware. So it is not just innovation that is being done at software level. It is also happening to a large extent on the hardware level. And the more better quality of sensors we put in, the better kind of way we are able to perceive the environment and more the number of applications. So yeah. So I think I have covered the basics. There are mobile robots. There are unmanned ground vehicles become part of it. There is unmanned surface vessels, that is water-based robots. There is UAVs. You might be already knowing that drones played the biggest role in the Russia-Ukraine war. So this is a huge industry. There is a company based in Mumbai and Ahmedabad, Idea Forge, that received an order of something like 200 crore rupees last year. For a large part, they were quite dormant, but suddenly in the last year, the Indian Army started buying a lot of made in India drones. So they suddenly grew to a very large this thing. So there is possibility in drones also. As of now, frankly, when it comes to manufacturing, we have a lot of components get imported, but yeah, it is in the nascent stage. But at least the assembly and the programming that has started happening in India quite a lot. So this is basically the robotics ecosystem: mobile robots, robotic arms. Depending on, there are these basic sensors which are required in a robot to do autonomous navigation. Then after that, depending on what additional accessories you put, it might become an agricultural robot, or a defense robot, or a mining robot, or a waiter robot, or a medical robot. I don't know. I mean, I'll just run through videos to make my point. But once you have got an animal or a machine, in this case, a machine in this case, which moves from point A to point B, as per the command, as per the wish of the human beings, and is also ability to has the ability to manipulate the environment by picking something from one place and placing it at the other end of the factory or whatever. Then you have some kind of an assistant, right? And that assistant can be required by anybody. You could require it on a personal basis also, and you could a doctor, an engineer. So just like computers and mobile phones are being used irrespective of the age of a person and the field he is in, uh, a machine which moves as per your wish can be required by almost anybody in any industry. So yeah, there is also a lot to do with the actuators, which I showed over there. So anybody who has an electrical background, you might be knowing that the evolution of actuators is playing a big role in the evolution of robotic arms. We want small actuators. So by actuators, I mean these are also actuators. My moving of the wrist, this is one motor, this is second motor, this shoulder motor, all these are motors. So we wish that we can have such small motors which can carry 30-40 kg. As of now, there are no available motors which are this small in size, like the human motors, and which are able to carry 40-50 kg. At the most, what the robotic arms that I showed, they can pick up 4 or 5 kgs, and they should also weigh 5 kg. Because if you want to have robotic arms placed on mobile robots, they should be as small as the human hand, right? Typically. So a human hand, typically from the shoulder up to here, it weighs around 5% or so of the body weight. So it weighs only 4 kg or 5 kg at the most, 3 to 4 kgs, and it is capable of picking up what 30, 40, depending on whether you go to the gym, anywhere between 20 kg to even 100 kg you might be picking up. I don't know. We have got extraordinary actuators that are given by God to us, but these kind of actuators are continuously going to be developed. Just like in the microchip industry, more and more transistors per chipset is what evolved the computer industry. Similarly, more and more power in smaller and smaller sized motors is what is going to drive the robotics industry. The motor should be as small as possible with lot of sensors in them also, and also controller to speak to the other motor. This is what we call as an actuator. So we need them small, powerful, and with sensors. So yeah, if you look at the industries, there are lots of them. So if anybody of you is thinking of doing some applications, typically like any other technology, be it mobile phones or computers, uh, if there are entrepreneurs in the audience who think that during my PhD time in 4 or 5 years, I will, along with my PhD, I also want to develop an application which should eventually become a sellable product in the market, then for them I have put up this slide. So like any technology, the highest margin you usually get in those areas जिसमें you either get to save a life or you get a take a life. So these are the two in typical industries are defense and medical. So as usual, critical applications are defense, bomb diffusal, medical robots, disaster response management robots. So if you have made a robot which can go in a fire area, or let us say certain water surface robots which can during times of this thing, just hold on. Let me just one second. So so yeah, I mean, disaster response management robots, these are all high cost, high margin, but less volume. But if somebody is trying to build something like this, it is there. Then industrial robots are actually not new. The ones that are used in manufacturing, they have been in the past 15 years. What is going to be new is service robots. Robots in warehouse and logistics, they are already in the exponential stage. And they might even come to maturity in another 10 years or so. But till then, चांदी है जो अभी warehouse automation में already existing है. Waiter bots are already coming up big time in Japan and in the advanced countries where the GDP per capita is such that buying a robot of a few $1,000s is cheaper than hiring a person. Cleaning robots, I do not know if anybody of you have purchased it. There is an Indian company also which buys some motors from outside, and they are making these kind of floor cleaning and floor washing robots, etc. Then construction has big potential. Even if they cannot replace the human being, they will most probably work as an assistant to construction workers. Some kind of, I don't know, not necessarily it will be called a robot, but at least the wall painting robot and all that, I have got many this thing from construction industry that can you just paint the wall, we are short of labor, etc. So in agriculture is actually, it sounds very good, but it is very difficult. I will come to that in the next slide, why making agriculture and defense robots is the most difficult. And then there is also the space of personal robots. People are trying to make personal robots, especially in all these advanced countries where there is a large old aged population, and they also live single life. They do not have all these joint family aspect which exists in India, or I don't know if even in India that is going down year by year. But there is a large requirement of some kind of a best friend for human beings in the form of robots. So even personal robots, that is going to be, that obviously has to be low cost, but it has the potential of high volume, just like mobile phones. So now, which one is easy to make and which one is difficult to make? Obviously, that which has more intelligence is difficult to make. Like for example, the simple repetitive options like cleaning robot or floor cleaning robot or dump sweeping robots. You use a microcontroller, Raspberry Pi, and based on that, people have made robots. Then even industrial robots are not, they already exist in the past 15 or 20 years, in which it is repeatable. That is, pick up some object and screw, pick up and place it somewhere else. That kind of a repeat operations, even if it is 5 kg, 30 kg, it doesn't matter. But not very intelligent operation. In fact, you will see a lot of industrial robots. I think I have shown it in one of the screen. I'll show it in the one of the future screen. But if you go into any kind of automobile manufacturing company, you will see the whole assembly line. A lot of major work being done by robots. One robot is doing welding, the other robot is doing screwing and all that. So in that also, the technologies are not that much. But if you look at agriculture or defense or construction, over here, the kind of sensors that need to be put and the kind of intelligence, that is artificial intelligence, you can say, that needs to be put, it goes higher and higher. Because in an agriculture, think of a operation like just cutting grass. It's not easy. There is no nicely cut. You can have a big machine, that is okay, but at a small level to pick up a certain fruit, then the robot will have to perceive the fruit. Is it really ripe or not? And then it will also have to pluck the fruit such that it does not break. So, and besides that, when the robot is operating, I do not know from which direction a dog or a cow is going to come and run towards the robot. There are too many external variable factors when it comes to outdoor robots. So this agriculture, defense, especially if you want to make them fully autonomous. Semi-autonomous is also semi-intelligent, by the way. So to some extent, semi-autonomous robots like a lawn mowing robot perhaps might be easier than a strawberry picking robot, uh, which will be much harder. So we get a lot of inquiries even from these agricultural universities who are trying to create apple harvesting, coconut harvesting, these kind of robots, because anyway labor is getting costlier. All these people who were at the lowest rung and who were doing the job of coconut harvesting, their children are not necessarily going back into the coconut harvesting field. They will rather, either their children have become engineers and got into the IT industry, or in case they have not studied too hard, they have come into the Ola and Uber taxi driving apps, and they are working over there. So either way, these kind of, there could be some things which human beings are not going to wanting to do. So large coconut oil manufacturing companies, they also sometimes sponsor research into coconut cutting robots, because they anticipate that the cost of the coconut is going to go up, not because the number of coconut trees are less, because they are not going to get labor. So while sometimes people keep on thinking that robotics is going to take away the jobs and all that, already people are not doing certain jobs like sewage cleaning. You are not going to find, as the GDP per capita also keeps on growing up, people are not going to do sewage jobs at all. They will over there also, and it is also very dirty and dangerous job to do, by the way, sewage cleaning. So there is one company in Kerala that I know, Bandicoot, which focuses just on making sewage cleaning robots. So these are some applications. Anything in which for human beings the job is either a very dirty job or a dangerous job, that we can be happily given to a robot, or it is desirable to be given to a robot, for both dignity of human labor, as well as the kind of threats like physical threats that are posed when you are when you're working in such dirty and dangerous environments for human beings. So yeah, so there are such companies also. So I think what time is it? But, yeah. So yeah. So what I wanted to mention is for those robotics entrepreneurs or 3-4 people who are doing MTech and PhD and perhaps they want to get into this. Before you decide on what product you want to make, in case the product requires multiple technologies, that somebody needs to be an expert in AI or a robot operating system, and somebody else needs to be an expert also in hardware, then before venturing into beginning the robot, venturing into beginning the creation of the robot, it is better to check out whether your team has that technical capabilities to deliver the solution for the problem that you want to solve. So yeah. I think I have already covered this. So even mining robots is also a good industry, but that has also been there. Like at IIT Kharagpur, they have been doing research in these mining robots. As you know, the number of people who used to die in mining industry, it was in the few hundreds in 2011. That has come down to only a few tens. But I mean, that I'm talking about death casualties. So if you go to West Bengal and Dhanbad and Jharkhand and all that area, uh, yeah, that's do occur in the coal mining and those industries. Over there also, if there are robots for either safety or some way to reduce, so using robotics and automation, they have reduced that to a good extent, and that is also going on over there. There in Jadavpur University, people are doing work in AI in the past 7-8 years. I have a video of brain controlled robot that they are doing. I'll see if I have that video over here. I will share that. So many of the people, like past 10-15 years, we have been setting up this robotics lab. There is we what we have also seen, there is the center for excellence in robotics sometimes becomes a misnomer. People have started focusing on center of excellence in agricultural robots, because there is a lot of agricultural universities who focus only on agricultural, or center of excellence in mining robots, defense robots, because one is getting just the robotic equipment in your lab, the other is you might also require sensors and expertise which are related to mining, like in IIT Kharagpur, or rehabilitation, where these people in Amrita University focus on rehab robots, or agricultural or defense robots. So whatever now, or in a construction industry, you can focus on that also if you want to create a center for excellence. Besides that, only if you want to begin with a robotics lab, then just a mobile manipulator having that is okay. But besides that, if you want to go more deep into it and focus on one of the technology aspect and become a champion of that technology for that by your lab, then focusing on one makes more sense. At the same time, even when it comes to somebody who is trying to venture into robots, then instead of being a jack of all trades but master of none, which is usually have what we become at the end of our graduation, we know everything about something about everything, but if we want to get into the robotics industry, since it is so multidisciplinary and it requires so many technologies, it is better to become a master of any one thing. So at the end of 1 or 2 years of you are trying for it, if you are an expert at ROS, then there is a lot of scope. I have a couple of friends who are just providing ROS consultancy and are minting good money. Or if you are good at hardware, if you can make those tires, or if you can do the system integration, I mentioned, or if you can make the actuators, or if you can make new kinds of cameras, anything in which you have got a mastery of one, then you need not necessarily become a system integrator and build the whole robot. You might be supplying just one component of that robot, which never perhaps existed before, and you got the patent for creating that new kind of a sensor for a new kind of application, and you clicked it. So there is so mastery in one will be more attractive. Either you want a job or in entrepreneurship, in both cases. Now, this robotics, in case you are thinking of setting up a lab, it works in open source software. That is the robot operating system. Uh, it's largely open source, but recently it was also purchased by Google. I will not get into the debate of open source being really open source and all that, because I think even Android is recently purchased by about an year ago or so. It is purchased by Google. This is one of the things I feel bad when I feel about our own country. We are not. We are. It is good that we are started to making our own robots, but we are not the mother of technologies as yet. So something like an Android, it still gets born and evolved in the US. Something like the robotic operating system, that is also evolved, born and evolved in some US universities. So I think even when it comes to AI, India still does not have a platform like a Chat GPT, and that owner of that Chat GPT also, I think he came and challenged us Indians some time back. So, so for that, maybe the IITs and all universities like yours, maybe if they can foresee what is going to be the next technology, and that for open source also, but if it is based in India, it makes a difference because anyway, I'll not delve too much into it, but there are geopolitical reasons of having open source also being owned by some or the other Indian companies rather than always foreign companies. Anyway, so intercompatibility of hardware along with software, you can check multi-purpose, etc. So this is the you have got mobile robots, robotic arms, you integrate, and then there are these different kinds of mobile robots. So what I showed, yeah, it's a bigger motor. That's all. So this is a bigger vehicle, then a slightly smaller vehicle. Then depending on whether this kind of an autonomous robot you want to use for agriculture by putting a lawn mowing behind it, or you want to use for defense, such that whenever a soldier is moving, the robot should just follow him like an assistant. So if there is an additional luggage or he wants more uh, patrolling to be done in a certain area, can there will be certain robots. Already if you look at the Indo-China border, there are some quadrupeds being deployed by them as well as by some by us. So those kind of patrolling robots, uh, yeah, these are also there. Yeah. So yeah, this is a bomb disposal. So depending on what equipment you put on an autonomous robot, now it can become this kind of a mine detection robot, or any other robot. This is a surface vessel. India does not have just a huge land boundary. We also have an enormous water boundary, which in fact, one of the attacks that happened on India was not from land, by the way. 250 people they got killed in 2008. That was from a naval attack. It was not a naval attack. The terrorists they came to Mumbai from via the sea. So just like today there are drones for air, who knows, there could be sometimes a requirement for drones on the sea. Large number of drones just moving around. So yeah, in defense industry, of course, there is a lot of this thing. So when it comes to robotic arms, the quest is simple. As I already previously mentioned, the desire is to make smaller and smaller robotic arms, which are also more and more powerful. And this company, Canadian company it is as of now, which we have been partnering for the past 12 13 years. So this is the main difference. On the left side, you have got the industrial robot. A while ago, I spoke to you about. Are you able to hear me, Dr. Ravi? I just
Yes, yes, we are hearing. We are hearing. Yes,
just in
continue.
case I got okay.
No, 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 no. Just I'm also in front of the computer only. Okay.
Okay. So this is the main. In the past 15 years, we have already seen the evolution of industrial robots, where in a huge assembly line, everything from painting, welding, single task repetitive operations, which increase the productivity of the machine floor or the factory is happening. In the next 15 years, we want to build robots which are multi-activity. So they are not going to be relatively dumb operations like painting and welding, but asking the robot to pick up something from one place and go and place it at another place. So it is multi-activity. It requires more sensors, more AI, more software. Because I have spoken only largely about we will give you the data. We are kind of somewhere we fit between the hardware and the software. We will give you the data to make sense of the data, to make algorithms which make the robot more and more intelligence is the job of AI and software engineers. So this is what is going to happen in the next 15, 20, maybe it will continue for the next 30 years. So this is, I do not know about AI, but this is an example of a machine learning robot. I'll just run the video.
Zelfs de meest efficiënte productielijn staat nog regelmatig stil. Bij industriële productielijnen zijn deelsystemen wel geoptimaliseerd, maar valt de productiviteit van de totale lijn vaak tegen. Het Mantis-project, waarbinnen Lambert Schoonmaker samenwerkt met de industrie, moet daar verandering in brengen. Uiteindelijk moet er een zelflerend systeem komen.
Het probleem is dat in de fabrieken de productiemachines heel erg duur zijn. Misschien wel bijna perfect, maar dat de productielijn als geheel...
You can just read it, I hope. Otherwise, you can read it, right? Dr. Ravi?
Yes,
Hello?
Aditya.
Yeah, you can read whatever I'm shown in this thing, right?
Yeah.
Valt de productiviteit van de totale lijn wel geoptimaliseerd, maar valt
Yeah, it is readable. It is readable.
Het Mantis...
Yeah.
It is readable. It is readable.
Yeah. Okay, fine. I'll just explain only.
Yeah, please.
So what they are saying in this video is, look, these kind of robots, industrial robots already exist, but even this large kind of industrial lines, their productivity can stop if there is some minor error in the whole factory. Everything stops. So for that, you might require a mobile manipulator which does a more intelligent thing. So that is what they are showing over here. This is the research being done in one of the universities. So they are trying to create this kind of a, let us say, robot in which instead of doing repeat operations, we want to make systems that behave autonomously. For example, this is a job of just clean the table. Now the robot needs to understand what to clean on the table and what not to clean. Is a half empty cup, is it okay to clear away or not? So these are all the questions that have to be posed by AI, and the robot actually gets better and better with more usage. Just like your Google Maps works much better with more usage. So you will typically see Google Maps which works much more in cities than in small faraway places, because the data that the Google Maps is getting is from a lot of phones. They are also recording the data, right? That this is a one way, this is not a one way. So when they give you a map in the cities, it works much better. Similarly, when you are doing mobile manipulation kind of an operation, there are already some people who get this kind of a mobile manipulator, and then they start developing algorithms for simple operations like clean the table. Now you might be thinking, who wants to clean the table inside the house? Do not think like that. Even within the industrial floor, there could be some table which needs to be cleared up, or some specific objects on a table that need to be picked every day and gone and placed somewhere else. So so with time and with machine learning and with artificial intelligence, I'm sure this is a 5 or 6 day course specifically related to AI and ML. Then there must be other speakers who speak specifically about these kind of machine learning and AI algorithms. I just showed you its usage and video over here. That's what. So yeah, this is the evolution of robotic arms, just like this Sunny Deol in this Damini movie. I'm sorry, I keep on putting a little bit of movie clips to try to make the subject interesting. but I hope. But anyway, as I already said, that the weight of the human arm is around 5 kg, and the evolution is to make lightweight yet powerful plus safe. Safe is very, very important. That is the most important word. Safe robotic arms. That is where robots are moving. Like we already have these kind of industrial robots in the past 15 20 years. We are moving towards smaller and safer and yet powerful robots. And when you put a robotic arm on top of a mobile robot, what you have is a mobile manipulator, which leads to even more applications. This is where it is picking up a glass and taking robot will move. So do not think that these 50 60 70 lakh rupee robots, or sometimes even 20 30 lakh rupee robots, are being used by billionaires to fetch a glass of water. This might be used somewhere in an atomic center or in a mining industry. It could be anywhere. So they are being just testing it in their lab over there to test the algorithms, etc., to try to move the robot autonomously for certain operations, that it should go to a certain place, pick up a glass depending on the sensor value and all that, and go and place it somewhere else. So this is the mobile manipulator, as I said. So this is what we over here do. We build customized mobile manipulators and give it to universities, academia, atomic centers, ISRO, and all of that. So this is, it is the same every time you got a mobile build robot. Uske upar there is a hand, a robotic arm, there is a camera, sometimes there are GPS, depending on what sensors you want to do. The everything is running on ROS. Some of the algorithms you can use the existing algorithms that are already developed on ROS, or else you can try to develop your new ROS algorithms for autonomous navigation, etc. And when you have got all the sensor data fed into your this thing fed into you, then you can do more also. This is the medical and rehab robot. Now you might be wondering, so if you look, he's actually, here is a person who is, so here is a doctor, and there is a person who is operating the robot. So he will, besides having accuracy and all that, quite possible the future robotics, future medical operations might consist of, instead of having 4 doctors, 3 doctors and 1 engineer. So that 1 engineer will be used to, probably the doctor will tell the engineer to move the robot by 0.0005 degree or something like that while doing a certain operation, etc. So it's not just about accuracy, it also saves money for the hospital, because hiring a engineer is, it's somewhat cheaper than hiring a doctor, right? So so there is also economics related to it. I know we engineers may not like to hear it, but there is a certain pay scale for everybody. So if you've got a very high cost surgeon, and if he can be one of the 4 surgeons can be replaced, though those the one who wants to pick up a hand and all that, it becomes cheaper also. So it is also economics is how it is wonderful how economics also plays a major role in the evolution. So yeah, so that is a medical robot, as I said. And besides it being used as a medical robot, in fact, this Kinova arm was started as a robotic arm for patients. So it is not being used only by doctors, but these kind of patients who have got muscular dystrophy, they have got limited ability to move their fingers. So using the fingers, they are given a joystick, and with which they move the robot. That's what. Then yeah, as you go ahead, this is ROS. Even if you do not right now have a robot, you can, there is something called as an RViz, which is a ROS simulator. You can do practice on the same. You can write the code on in ROS, and it works in RViz also. So I just mentioned this in case in terms of AI you just want to, and whatever you do in the simulator, that also works in the real environment. Once you have got the hardware, you can test it also, for those of you who do not have a lab in access in the in your university. So there are different ways to control the robot. It is not just about the joystick. You can do motion tracking like this, or you can mix robotics robotics with virtual reality by controlling it with a headset. So, yeah, using a virtual reality headset, you will have to match the environment with the real environment, and accordingly, it should also work on the physical environment somewhere else. Because after all, more people will use the robot if it is easier to work with the robot. For example, we everybody can use the computer mainly, as you know, because of the mouse. If there was no mouse and if everybody had to use a keyboard, then interacting with the computer becomes a difficult job. So this is where a human computer interface, HCI, objects come into picture. Similarly, when new robots are developed in the market, what is called as HRI, human robot interface, new devices need to be developed, so that even a farmer or a doctor or a 5-year-old or your 85-year-old grandpa should be able to use the robots without having to learn programming or without having to even use a joystick. They might be doing their regular actions and the same action happens somewhere else, or happens by them. So only then, if you develop better and better human robot interaction devices, will the robot be used more, and there is more chances of the robot being sold also more. So that is the world of HRI, and people, that itself is an industry also. So look, this is a haptic device. This is another way of controlling the robot. You move your hand over here and the robot is moving somewhere else. So this is also part of the robotics industry itself. Or you just using brain signals. So there could be some patients forget about moving the hands and all that. They just have to think about doing it. So this, they are trying to interpret the signals, brain signals, but this guy can still move the neck even without moving the neck. In Jadavpur University, Kolkata, there is one Dr. Amit Konar who has done without research. Those people do not even move the neck. They are just as it is, and then if they just think about moving the robot right, left, up, down, and according to the EEG signal, they are doing their robotics, this thing. So that that is where PhD, 2-3 people did PhD on that. Then new people are trying to do PhD to even play table tennis with the robot. Of course, it is in a very nascent stage, but it is useful. So it is for those kind of patients who are in a completely paralytic state. So for them, it will make a huge difference in their lab if somebody in AI can analyze what is happening in his brain, and that person will not have to depend on anybody to have a glass of water. Otherwise, they are fed water and given food only when somebody comes and tends to them, because they cannot even speak or anything. They can understand everything. So robots can be very useful and transforming for those kind of patients also. I think I might be running out of time. I'll just wind it up. Okay. It's still 7:30. I'll leave the. So there is a lot of job opportunities to design the body of robots. Electronic engineers can develop new sensors. In electrical, you can develop some better batteries, etc. Computer and IT engineers, mathematicians who want to develop new algorithms, and then AI programmers who actually develop it. And then you can collaborate with either a civil engineer to develop construction robots. Some doctor might come to you and ask you to make a medical robot, and so on. And just like fashion designers, there will also be job opportunities for robot designers, because at the end of the day, if you want to sell a robot in the service robotics industry, just making it functional is not good. It also has to be aesthetically good looking. That is why the reason why Apple sells more than many other devices. It is not just the functionality, it is even the aesthetics. So similarly with robots also, how the robot looks, uh, how the user interface is, how it interacts with the robot, all that aesthetics also play a major role. So what is called as design and design engineers also play a role in when you are evolving towards service robots. No, we have already seen this. I'll just skip this. So besides having all these robots, the actuators, I'm just going to skip this now. So depending on what robot you are building, it can be used for logistics, medical. We have already seen some videos, etc. So yeah, we have been giving this. This is a robot that is made by us in India in collaboration with an Indian researcher when he was doing his PhD during his IIT Delhi. While he was doing his PhD, he started doing his research. After that, we funded him also, and he built this parallel robot. Now this is the Stuart parallel robot. So we have made this and some other robot also. So what I showed previously was a serial robot. This is what got a parallel robot. It's like a crab. It is used for stability. It's a stored force platform. If you are in postgrad, you might be already be knowing about this. So yeah, so we are also making some of our own mobile wheeled robots also. Currently, I do not have that with me. Otherwise, I could have shown the demonstration of how the robot that we are building in India itself, in Tamil Nadu, in Coimbatore. I'm based in, but my partner is in Coimbatore. So this is built. This is made in India, the whole thing. And I think to Dr. Ravi Kumar, I think we sold this one of this robot about 2-3 years ago when he was at Vignan in his
Yes,
previous
yes, yes,
university.
yes. Oh,
Yeah.
yes.
So this kind of a robots also we make. Now we are making not only these small 5 kg robots, we can make up to 300 kg. So if somebody wants it customized to create a flight simulator, we can do that in India. So and this happened. So do not think that only foreign universities can do it. Even Indian universities, if they collaborate and if they can provide deliver, then even small startups like ours get benefited. The person who is doing his PhD or whatever also gets benefited. And at the end of the day, we are also contributing to make in India in our own way. So in fact, India needs more and more such stories of making our own products and building our own companies also, besides doing great jobs also, which is also fetching India a lot of money. So yeah, the typical platform is the same for mobile robots. You have got a mobile robot, there is a CPU, sensors, ROS enabled. The architecture is the same. I have already spoken about ROS. Then depending on what kind of animal you want to create, you can put 2 hands, 4 hands, all sorts of sensors on it. You can also put your own new sensors, because most of the platforms that we give the power and communication also to work with the controller inside that robot, which is a Nvidia Jetson, or I think that is, these are, Nvidia is usually used by AI, right? So this also we put. One robot can talk to another because of the ROS architecture. So the mobile wheeled robot speaking to the drone, and they being able to interact with each other, that provides an even higher level of intelligence. Just like there is an internet of things which is called the IoT, there is also a desire to create an internet of robots and things, because if we want to manipulate the environment and not just get the data, then we will need that. Of course, that will also require a 5G structure in place, because when you are playing with the environment, there shouldn't be any latency. So if there is some sensing that happens in Delhi, and accordingly some robot should be moving in Hyderabad, the internet lag should not be in 1 or 2 seconds. For some applications, it has to be in microseconds. For that, 5G environment becomes one of the enabling platform uh, to for those kind of real-time applications over large distances. So this haptic devices, indoor GPS, new kind of sensors are also coming. I think I'll wind it up. I can speak for any number of time, but I'm going to wind it up so that we take up some questions, at least in my last 5 minutes. And yeah, this we have been doing for past 12-13 years, setting up labs, etc. And this is finally my email ID over here, contact at Newgenix, and this is my WhatsApp number. And what I wanted to say, especially if you are doing MTech or PhD, you have got an opportunity where you start in the lab, whatever project you are doing, but it not end in the lab. It could become part of a bigger story in which you develop something new altogether. So that is going to be very good if you do that. If you are going for entrepreneurship or even in terms of a job, it makes sense. So I'll end over here. And if there are a few queries, we can do that. We have some 5 minutes, I hope. So thanks, Dr. Ravi. I hand, yeah.
Yeah, thank you, Mr. Aditya. Thank you for accepting our request. Now I'm requesting the participants. I already enabled your mic. If any participant have any questions regarding about Aditya talk, you can switch on your mic and you can discuss. Yeah, Aditya, actually, few participants they're asking your PPT. Please share the PPT to me and I can share. Actually, anyway, we need to share in the ACT portal. Please share the PPT after completion of this.
Okay, I'll share out of that whatever of the this thing we can.
Yeah.
Thank you,
Yeah.
sir. Somebody said wonderful, I think so.
Hello,
Thank
sir.
you.
Yeah.
Good
Yeah,
evening.
please,
Hello,
sir.
sir.
Please. Yeah, please.
Yes, sir. This is Paramasivam from Rajalakshmi Engineering College, sir.
Yes.
Sir, let me know that the design consideration when we are going to develop the steward platform parallel robots, because steward platform is a parallel robot, no, sir.
Yeah. So frankly, this was developed by Dr. Arun Dayal Uday. I won't be able to get into the details of how it was developed, but this guy, Dr. Arun, he's quite an expert when it comes to.
Yeah, Dr. Arun is in assistant professor in ISM Dhanbad. Actually, he was the developer this product, and this Newgenics Corporation Private Limited, they are selling this product in market. Is it correct, Aditya?
Yes, that is right. So I'm not a technical expert. I'm a techno-commercial guy to begin with.
They are making
I
commercial.
can tell you about finances also a little bit of technical from whatever the PhD people like Dr. Arun put in my ears, I can tell. But they are using some actuators from robotics, frankly, we can tell you. But it is not about which actuator, it is about the controller and
No,
how
no,
he has developed the
they
controller.
are
You
using
ask
all
Dr. Arun.
our dynamic cell motors. Dynamic
Yeah,
cell.
dynamic cell. Yes.
Dynamic cell only they are using. Yeah, the participants. If any participant, if they want to give any feedback,
Hello,
you
sir.
can give it. Yeah, please.
Yes.
Sir, it was very information and
Yeah,
आपका
please switch on your camera and then speak. Yeah, please. Aditya, please stop your sharing. Please stop your sharing.
Okay.
Yeah,
Okay.
I'm requesting
Yeah,
participants,
I'll do
please
that.
switch
Yeah.
on your camera and then you
Yeah,
can
yeah.
speak.
I'll stop sharing.
Yeah. Yeah, please. Someone is going to give feedback, please. Hello.
yes, sir.
Yeah, please.
Yes.
Sir, it was very information session, sir. And my question is, sir, uh, uh, in India, where is the gap, uh, like in software or in robotics? Where is the most gap is there, sir?
So actually, the gap exists not just in India, worldwide. There are a lot of gaps that need to be filled in both hardware as well as software. I already mentioned to you, new kinds of sensors are continuously being evolved. There is a desire in almost every field that new kinds of sensors and software is required if we want to make more and more intelligent robots. I already spoke about new kinds of, for example, the camera depth sensor. About 4 years ago, now the camera depth sensor is looking in only one direction, 72-degree field of view. If you put 5 cameras together, you get a 360-degree field of view camera depth sensor. You put all the data together. So there is one company, only one company as of now in the world, which is doing that. It is obviously going to sell at a premium. But if somebody develops more of those kind of sensors, that is an example of hardware requirement. Altogether, new sensors which never existed till now are required. That will require another half hour, 1 hour of me talking. So I'll stop with one example. Even and then when it comes to software, there is no end. Right now we are doing an apple harvesting, whether by just looking at the apple, whether it is ready or not. that is a software problem. So you can see any number of problems like that. We have got work for the next 15, 20 years in both hardware as well as software.
Sir, one more question, sir.
Yeah.
Uh, Sir, I'm pursuing MTech, sir. Uh, so in our college, there is no lab, sir. So there is a lot of theories going on. So how, as a student, how can I explore and how can I learn practically and how can I how can I explore more and more? So,
So two ways of doing that. One is you go through the ROS simulator. Suppose you write a code. By the way, learning ROS itself is not that late. It takes several months and all that. If you want to go into open source programming and all that, otherwise get a few actuators, like low cost one. Take out a budget of 30 for 20, 30,000 personally. Buy a few actuators and try to build something. Trying to do is the best teacher. You will definitely fail. There is no problem, but that is what is teaches. Buy 30, 40,000 worth of small actuators. Try to build a robotic arm yourself. That will teach you both the theory and practical applications than holding a book all the time. If you want to go
yeah.
towards the hardware side. Otherwise, the only other option is to pick up a phone, call some company who is trying to do that. And if your existing expertise matches at least faintly with them, they might want to work with you, just like what I worked with Dr. Arun to develop a parallel robot.
Professor, actually, I was when in a triple ITL, I was doing my PhD. So over there, some stuck means a problem, means some robotic arm and some uh, means cognitive something is there, and using brain signal, hands should be moved and pick the object. Okay, such type of scenario we are doing in a research. But that means we have to move our hand like that, means, and then our means hand will not work properly. That's a problem definition. So how is it possible to make using means actuator something same robotic hand from actually from which place means our university purchase this brain signal cognitive engine. Okay, so so that's a problem definition. Okay, so what exactly solution you will give, miss, for a person who is handicapped? Okay, for that you're supposed to make a robotic hand. Okay, and there's some designed just search in a search engine, and there already some everything is situated, and it's a mapping brain mapping, your neural network, the hand will work. Okay, so in a programming point of say that actually work, but just we are moving hand, then not working properly. So in a
Yeah.
real time scenario, we would like to make for a handicap this robotic arm. So how is it possible? Will be possible? Give me some your input. Thank you.
Okay. So again over here also, na, to
You
share.
understand my point?
Yeah,
Problem.
yeah.
Yeah, Aditya,
Uh,
please try to
so,
You
answer it.
anyone please give.
And we are going to close your session. Actually, another keynote
okay.
speaker already joined. Please,
Okay, fine.
please give
So long
answer.
story cut short, now please on Google put up Dr. Amit Konar, Jadavpur University. This guy, this person has been doing only brain controlled robots for the past 12 years, taking out three PhDs also. One of the person, he is controlling the robot without even moving his neck like this. You will be able to see the Kino arm being controlled by that. When you came to sensors, you get an easy headset of emotive for 50,000 rupees also, and then you get a higher headset which goes into lakhs of tens of lakhs of rupees also, depending on the quality of the signal. In spite of that, it is not at all easy, and not because it is difficult to move the robot. Brain signal interpretation, that itself is a very nascent technology, I will tell you. I do not
Yeah.
see it happening in the next 4 5 years. It is going to take 20. I think it is going to take 15 20 years at least.
Okay, thank
Yeah,
you.
the thing is
Or
that we
maybe
are making a robot for
Uh,
for our society. We are making a such type of research. Okay,
yeah, yeah.
but that's a revolution, na? If somebody using brain control the
Yeah.
object for a handicap, so it's a very hot area. So just please
Yeah.
keep in a loop and try to solve this problem for a human
Okay.
sake. Yeah.
Yeah.
Okay, thank you,
I would wish you
Aditya.
also.
Thank you. I think another keynote speaker he's already joined. He's waiting. Thank you. Thank you. You can
Okay.
leave the meeting there, Aditya. Thank you.
Thank you, Dr. Ravi. Thank you, all the participants.
Thank you.
Sir,
Thank you.
the name of the doctor name what, sir?
Dr. Amit Konar, Jadavpur University. Okay.
Thank